Hi, welcome to another tutorial to guide you through how to use the isotope pattern overlay script. So what the script does is that it takes a supplied mass spectrum and overlays the predicted isotope pattern onto it. So this peak is a continuum peak and the green bar is the predicted isotope pattern. So this is just an example of a isotope pattern of a palladium species. So now going back to PyCharm, we're going to open up the isotope pattern overlay script. And this tutorial we are going to go over a few examples and sort of how to troubleshoot them, as a data file can be really different depending on the type of aspect data you have. It could vary between resolution or just the type of peak that you have. So we're going to look into that today, and please bear with me in this video. So on top of the script there is a list of instructions of what you have to provide and the parameters that you need to input. So first of all, you have to provide a file path of your experimental spectrum. So this can be an Excel file, raw file, or MZML. And today, the example, I have a Excel file, so we are going to look at that today. Then you are going to specify the sheet name, and next you want to specify if there's any header lines that you want to skip. If not, you can just set to 0. And next you want to set the species. You want to define the species, so you need to know the molecular formula of the species. And you also get to specify the color, and 3, you get to choose a preset, and we'll get to that part later on. So here you want to provide the file path, and I'll show you how it's done. So I put my file into the validation folder that it's part of the PythoMS package. And mine is a Excel file. And what you have to do is to provide the file path. So you want to click on the last tab over here, and then right click and select copy address as text, and you just want to paste it onto line 22. And once you paste it, you notice that the slash, it has to be 2 slash in between the folders. That's just how PyCharm runs the script, so you have to add one after you paste them. And if you messed up, you can always just check Control Z, and then it will go back to where before you edit the script. And next you want to copy and paste the spectrum name. Now we're just going to click into the Excel. So here's my spectrum list. Column A is the MZ ratio, and column B is the relative intensity. So here I did leave the first row empty, so we're going to have to change that in a bit. Oops. So if you paste your spectrum list onto the very first column, then you don't have to do anything with the column offset. But if you start your spectrum list in, say, column C, then you want to skip two columns. Okay, next we'll just have to define sheet name, but since it's already in sheet 1, I'm not going to change anything over here. But if you have it in sheet 2, then you want to input that into sheet 2. The next thing we'll do is to provide the species molecular formula into lines after 38. So any lines over here, it will work. So on the script that you downloaded with, this whole area they all will have like a pound key at the very beginning. So what the pound key or character means is that when you have this, PyCharm will not run this line, meaning it turned this line into a comment. Or yeah, it will turn it into a comment and not as a command. So if you delete the pound, then that line will turn into a command. So PyCharm will know what peak to select and overlay the isotopic pattern with. So first you want to provide the molecular formula, and then you get to customize the color of the predicted isotopic pattern bars. So here, for example, I have a palladium species over here, and this is how the pattern looks like. And next thing, you can just copy the molecular formula and then paste it onto PyCharm. So here I'll start a new line at 46. Here I paste it. Be mindful of the open quotations. And then I just copy the previous line, the color. So here, the color you can use, you can define the color by the hex code or RBG. And down here there is still a list of parameters, so just how the style you want the figure to turn out. So here it says pub, so it will be publication style figures. And you also see other parameters over here. So if you read over them, you can customize the aesthetic of the figure. So here is a list of explanation instructions of what each of these parameter means. So now going back up here, now we're going to double check what we have, and then we can simply run it. Okay, so now it says it's running and in the writing directory. Okay, so now we go back to the validation folder and we're going to open it up, the figure. Okay, so there's how my figure looks like, and it does not look very nice. So let's just paste it onto Microsoft Word to see how it actually looks on paper. Okay, so the problem with this figure is that the predicted isotopic pattern follows the resolution of the given mass peak. So if you have a low resolution mass peak, then the isotope pattern will appear as a block, like what you can see right now. And so we're going to try a few things to see if we can bypass it. And before you do anything, you want to rename your figure if you want to retain it, because it's once you run on the same species with the same name, then it's going to replace that figure. Okay. Okay, so now we are going to look at the rest of the parameters and see what we can add and try out. And here we have a bunch of explanation of each of the parameters that you can do. Some of them is for aesthetic of the figure, and some of them is to define mass peak, resolution, and so on. And here is the MZ range that you can customize your figure to show. So we're going to try a wider mass range here. Then you want to delete the pound key and then let's run it. Now it looks like it included another peak in there. Now that we set the range to be a little bit wider, let's take a look of the figure on Word. So here's the previous figure. Okay, so the isotope pattern is there, overlap with the peak, but that's not exactly what we want. We want to see just that peak. So what we can do, okay, now we're gonna rename that figure just to keep it to compare. So going back here, so we'll not use the MZ range for now, and let's just find out the resolution of this particular peak, and let's see. So in order for PyCharm to run this line, you want to delete the pound key, and then we can just run this. Okay, so the res label of this peak is 546. So that is quite low. Just for reference, we're gonna paste it onto Word as well. And now going back. So one way to bypass this low resolution problem is that we can go back to PyCharm and give a resolution value that is higher than the res label of the peak. Now what this does, it doesn't change the resolution of the original peak from the raw data, but it tells, but instead it gives out a much defined isotopic pattern. So here we'll just try a number. We'll try 800. Technically, any value will work. That is, any value that's higher than the res label should work. And let's see. Okay, this is more what we want to see. Okay, let's rename this figure and paste it again on Word just to see how it looks like. Yeah, as you can see, it gives out a wider mass range, but it's not exactly doing anything with the mass peak. So what we can do to make it look more aesthetically pleasing, we can keep on increasing the resolution, or we can just change the bar width. But we're just gonna try one thing at a time. And let's compare it on Word, and now you can see the top is 800 and the bottom is 1000. So it does appear that the bars look a little bit more refined, but in that case we might have to use a really large number. So now we can try adjusting the bar width. Now go back to PyCharm window. And let's just try 0.5 for now. Let's paste the picture or figure into Word again. Oh, okay, that looks more like it. So this is what, after altering all these parameters, we can get this isotope pattern overlay figure. So this is what you have to do when you have a low resolution peak. But if you have a high resolution peak, then you don't have to go through into changing all these parameters. You can simply just provide the molecular formula and the color, and then you can just run the script. So let's see another example. So you're going to try another palladium species in the same data file, but with the extra arrow ring, so it'll have a different mass peak. Okay, so now we're going to copy and paste the molecular formula. Then this time let's change the color setting. So like I said earlier, the color setting can be provided in the hex code or in the RGB format. So let's just try looking at another color. So we'll try maroon. So you just want to copy and paste the whole code, including the pound key. Okay, and now we change another format, will be thesis, and we'll just let it run. Okay, now we paste it onto Word, and as you can see, this is a different mass peak. They share a very similar isotopic pattern because they're both palladium species. But yeah, there we have it. And now we can also do one more example. Let's try running one of the validation file that comes with the PythoMS folder. So this would be in the validation file, the LY 2015 file. So this one is AMZML. So you don't have to define any sheet name or anything like that. So here we're just going to delete the pound key. So the original script that comes with the PythoMS folder is written with this particular example. So we can that's why we can delete the very first line of the species name. Now let's just run it and see what we get. Now let's look at it with Word. Okay, so we do not see any bar, but it's a very high resolution peak. As you can see, it was 4,000 something. Okay, let's rename this file and go back to PyCharm. And what I did over here is that I delete the pound key for the bar width to see if that would make a difference. Okay. Doesn't seem like it. Okay, so what we'll do now is to go over to the sim norm explanation of this parameter. So what it does is that it normalizes the isotope pattern intensity to a specific value. So let's just try 100. So yeah, so let's delete the pound key and put 100, and let's run it. Okay, now let's open it up in Word again. Ooh, okay. So now it looks more like it. That's what we want to see in the figure. Now we can go back to PythoMS and switch some parameters and make it look more nice. So here again we can alter the bar width again. And voila, there you have it. But it looks like this particular data file just have a really off calibration, but that's okay. And that is all for this video. If you ever run into a problem while running the script, please let us know. You can go to GitHub website and go to the PythoMS homepage and click the issue tab and let us know what type of error message you encounter, and also send us your raw file so that the creator can look into it for you, and this way we can do more debugging and make the script better to process different types of data. Thanks for watching and good luck!